Cool. All right. Well, hello, everybody. My name is Thomas Morris, and I'm going to teach you how to get rich quick with Bitcoin, but not actually. I'm going to talk about how Bitcoin is way overhyped, and so are all the other smart contracts and the blockchain. And I'm going to tell you why. Because it may be something worth getting interested in, or it might just be a complete waste of everybody's time. So a lot of you have probably heard things on the internet like, oh my God, with blockchain, you're going to get rich quick. Or, oh my God, it's the next generation in finance. Or, oh, try to take my money now, Obama. That's what I thought. It's on the blockchain. Or, this is going to change everything. Oh my God. Or if you're like me and you've been watching a lot of crypto videos, your YouTube is inundated with stupid videos with people's faces on them, talking about how things have changed, or some might think I'm crazy, or now is time to get rich quick. And is Polkadot going to the top? Who knows? Click here and you'll find out. But okay, so what exactly is blockchain? And well, how does it work? But I hear you saying, Thomas, I keep hearing the internet talk about NFTs and smart contracts, and what is all that? Well, that's what we're here to talk about. I'm going to tell you about the blockchain and how it works from a programmer's perspective. And we're also going to talk about smart contracts and how they work exactly, and also why they enable new and I think kind of interesting things. We're going to talk about what they might be able to be used for. And then also, to insulate myself from any criticism, I'm going to also ask you guys if you think it's worthwhile or if it's just a waste, because I'm interested, but I don't know, honestly. I don't know if it's just useless. We'll see. We'll find out. But anyway, in order for us to be able to talk about this in an educated manner, we got to talk about the blockchain and how it works. So, prototypal example, Bitcoin. All right. So the way Bitcoin works and a lot of other blockchains in general is that you just have some global state that contains how much money everybody has. And granted, I'm going to massively oversimplify this to save everybody's time, because otherwise we would talk about nitty-gritty stuff and we would argue over details, and that wouldn't be fun for everybody. So anyway, you have this massive global state that just says, hey, Alice has 10 Bitcoin and Bob has 10 Bitcoin and Cassie has 10, whatever. And then you also have these blocks that just are like a snapshot of what that state looks like at any given moment in time. So if Cassie sends some money to Alice, the next block will show her having less money and Alice having more or whatever. And pretty much everybody can view this. Everybody can go and look and see how much money is in each wallet at any given time. And we already talked about that. And also each block that's in here, each snapshot, contains a reference to the previous block before it. And that's important, but we'll talk about it in a bit why it is. All right, so if we just have some basic example, we have Alice and we have Bob and we have Cassie, and they each have 10 Bitcoin. I don't know why they have 10 Bitcoin, because that's a lot of money. That's like $200,000 each of them has. I mean, probably last week it was like $300,000, but you know, the price keeps going all over the place. But let's say, for instance, Alice wants to send Cassie $20,000 for whatever reason. That means that the next block in the blockchain is going to look like this. She's going to have one less Bitcoin. Cassie's going to have one more Bitcoin. And that block is going to have a reference to the previous one behind it. And then let's say that Bob over here, he wants to send $100,000 to Alice. Definitely not for drugs or anything illegal, because that would be crazy. And so then the next state will show him having 5 less and Alice having 5 more, and so on and so forth. And we just have all these little snapshots, one after the other, you know, showing who owns what. But in order for this to work, in order for this public ledger to be trustless and for everyone to come together and decide what it is, everybody on there has to agree on who paid who, what, when. So how do you do that? Well, this is where miners and validators come in. So Bitcoin mining. Mining is pretty much the process of how these new blocks get added to the blockchain. So in other words, it's how we make everybody agree that Alice paid Cassie her damn money for drugs and other not illegal stuff, probably. And so in order for us to talk about that, though, we have to talk about hash functions. Oh, man. All right, this is getting deep. So what are hash functions? I don't know. Well, actually, how many of you know what hash functions are? Everyone? Well, not everyone, actually. All right. Somebody, I think, raised their hand, but I don't know if that's actually true. I don't know. Okay. Well, anyway, for those of you who don't know, I'll just try to like boil it down to like the simplistic bits that we actually need. If you ever look at your git commit log, you'll see these funny letters and numbers. That's just basically a number that's represented in hexadecimal, and it's a really big number. And these are the outputs of a hash function. So what does that mean? Or what exactly does a hash function do? Well, they have some special properties to where if you put in an input, you'll get some output. And if you change that input by just a little bit, you'll get a massively different output. And it's like really hard to predict what it'll be. So for instance, if I put in the string crypto is a Ponzi scheme, and we get F5AFED710, all that. And if we just change it a little bit, if we say capital C crypto is a Ponzi scheme, we get a completely different output from there, a different hash. Also, another thing is that if you have the same input, you'll always get the same output. So if I tell you buy Prague real estate if you actually want to make money, then you'll get this output. And if I tell you this again, 5 days from now, you'll still get the same output. And also, if you have some output, it's really, really difficult to guess what input you put into the hash in order to get out of it, right? So if I say, hey, there's some hash thing here, it's 20F77C135, guess what the input was in order for me to get that output? Well, there's not really some function you can put it in and be like, hey, undo this hash and tell me the input. That's really hard. It's just too difficult to do. You pretty much just have to kind of guess or use hash tables or whatever, but you just kind of have to guess. So like, I don't know, did I say I'm going to become a crypto billionaire? No, because that hashes to 9ED83. Did I ask, I'm going to get rich on Dogecoin? No, I did not. That hashes to 53A26C, blah, blah, blah. What I actually said is get out while you still can, because that hashes to the actual hash that I just told you. There's one final thing about hash functions is that if you have two different inputs, they should almost never hash the exact same thing. And there was this hashing algorithm called MD5 back in the day, and that was found to be insecure because some smart person on the internet found out that if you take these two really long strings or really long numbers, and if you hash them, you see they're minorly different. Like you see in the fourth row on the left side, the fifth to the last character is an A in the first one, and it's 2 in the second one. Those hash the same thing. So MD5 was found to be, nope, not a good hash. We can't use that one anymore. So, all right, just a quick recap then on that. So the same input always gives you the same output. It should be really hard to guess the input just by looking at the output, and two inputs should never hash the same thing. So you can kind of think of hash functions as a sort of like one-way kind of function. Like, so if you have this input, then it's really easy to get this output. You just throw it into the hash function and it poops out the output. But if, let's say, for instance, you want to get a very specific output, like some number that's less than 10 million, I don't know, like 8,000 or whatever, it's really hard to guess what that input should be. You can't really go backwards. You can only kind of go forwards. You just have to brute force your way in order to get the output. So that's hash functions. Oh, all right, let's get on with it. So how does this all work? How does mining actually work? That's why we're here, right? So the way it works is that we start off with a certain state, with everyone having $200,000 of Bitcoin, and Alice wants to send Cassie $20,000 for whatever reason. So she makes a transaction and she says, hey, I'm going to pay her 1. And so the miners go and take this transaction, they apply it to the current state, and then they get the output, right? So Alice loses 1 money, Cassie gains 1 money, and that's the new state. Cool. All right, this is going to be the beginnings of the new block that we're going to try to mine. And also, because I said that each thing references the one behind it, you see that we have a reference, this previous thing, to the ID of the previous one. That red 1FC3 is the ID of the block that came before it. Cool. All right, so we now need to find the ID of this new block. But how do we do that? Well, we have to hash everything that's inside the block in order to get the ID. But also, there's a catch. ID has to be less than 10 million. Well, it doesn't always have to be 10 million per se. It has to be less than some number called the difficulty that makes it like really hard to make new blocks. And I hear you say, but Thomas, that doesn't sound fair. Why do we have to make it hard to make new blocks? Well, wait a minute. That's on purpose. It makes it harder to hack. So just hold your horses. So let's say we try to hash everything that's in this block and we try to see if it's less than 10 million. that's actually what the hash comes out to, which is a giganto number that I don't even know how to pronounce. So that's definitely not less than 10 million. And so then I hear you say, well, what are we supposed to do then? You said that if you cache the same thing over and over again, you always get the same output. How is that going to work? Well, the way it works is that we just add some random number called a nonce to it to see what happens. So we'll add a nonce here. We'll say it's 1 in this case. We hash all that together, and that equals that. Is that less than 10 million? No, it's not. So we just try another nonce. We try 2. And again, though, you'll notice that we can't go in reverse. We can't say, oh man, well, what's a nonce that's going to give me something less than 10 million? Because of the way hash functions work. You have to just try a bunch of nonces until you get whatever output you want. And if you don't get what you want, try again. Sorry. So then we just try a nonce of 2. That comes out to this. Nope, it's not less than 10 million. Oh no. And then we just try this over and over and over again. And then let's say eventually we find that this nonce of 729AF, blah, 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 if we hash that with everything else, that comes out to 233C. And that's less than 10 million. That's about like 9,000, something like that. So this new thing becomes the ID of this new block. And also the nonce gets included in the block too.
Sorry, let me just interrupt quickly. I guess the food's here. So let's keep going with the presentation, but please, while the presentation's happening in an orderly, quiet fashion, go and get your food. Thanks.
All right. Wow, nobody's moving. I hope this means that it's interesting for everybody. All right, so yeah, we found this random nonce where if we hash it to, now everybody's getting the food. All right, so if we hash this nonce with everything else in the block, it ends up being 233C. 233C is less than 10 million. So hooray, that's also all added to the block. And then let's say Alice was the one that was mining all this and she found this nonce. She's like, oh, hey, everybody, I got the new block. I found a valid nonce. It's going to look like this. And then everybody else can then verify that she's actually telling the truth. They can just plug all this stuff in and they see, oh yeah, it is less than 10 million. Oh yeah, it does equal the ID. Huh, okay. And then this block pretty much becomes part of the network. That just becomes the new thing that everyone decides is the next part of the history. And then on top of that, Alice is rewarded 6.25 Bitcoin, which right now is about equal to $150,000 for her hard work. And then everybody just picks up new transactions and they just continue on. And that's just how it goes. So the steps are, once again, is that people submit transactions like Alice sending money to Cassie. Then the miners choose whatever transactions will go into the block. For the sake of this, we're just saying 1 transaction per block, but there's actually several that go in. We're just trying to keep this simple. And then from there, the miners take this transaction, apply it to the current state, get a new state. Then from there, they have to figure out what the ID is going to be. The ID has to be less than a certain difficulty number, like 10 million in this case. And they have to find some nonce where if they hash everything together, it equals less than 10 million. And so they guess over and over again. And when that happens, it all becomes part of the history. Hooray. So if you notice, though, every block ID depends on everything that's inside the block. And the block also contains references to the ones before it. And it's also really hard to calculate a new ID. And actually, in terms of Bitcoin, that difficulty is calibrated to where it takes about 10 minutes for everybody in the world trying a bunch of different nonces all at once to guess something right. So all the miners in the world will probably find a solution once every 10 minutes. And so that means that a block gets made once every 10 minutes. And also, everyone else can check your work. So you can't really cheat because then they'll just be like, nope, it's invalid. Forget it. Keep moving on. We're going to just ignore you. And so how I mentioned that each block kind of references the one before it, that's really important because let's say you want to cheat and you want to change this state. Well, that's going to change the ID. So that means you're going to have to find a valid nonce for that one. And then the next block here references your new ID that you're going to have. So that one means you're going to have to change this block as well. Then you're going to have to change the next one. And oh my God, it's just so exhausting. All right, but let's say Alice is clever with her happy little smile and her friendly looking demeanor. She thinks she's going to cheat the Bitcoin by making a new block right at the very end. Well, let's see how that's going to work out for Alice. Well, it's not going to work out very well. Let me tell you what. So what happens is that let's say she's like, I want to say Cassie gave me all of her $200,000 in Bitcoin. I'm going to be the master. Well, all right, so she goes and makes this evil block, and it's red because, you know, it's cheating. And so in this one, she's going to have 20 Bitcoin, and Cassie's going to have goose egg Bitcoins. But now she has to go and calculate the right thing. She has to find a nonce to where she'll get the right ID. Well, thing is that she's going to be here trying to find a nonce while the entire rest of the world is out there trying to also find nonces and mine new blocks and everything else. And there's like hundreds, millions of people out there mining, and they have about 99.99999% of all of the mining hardware in the world. And she's just working on her company laptop trying to make some extra money on the weekends. So there's no way that she's going to be able to guess these numbers faster than everybody in the world put together. So pretty much while she's here trying to find a nonce and blah, 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 then, well, somebody else in the world will take some transaction and find a nonce. And that takes about 10 minutes, right, for everybody in the world to come up with one. And then, okay, cool, she's still trying to find this for her transaction because she wants to make this happen. All right, well, then somebody else, odds have it, is going to find something and make the next block. And then what happens is that whenever there's a longer chain here, for instance, whenever new blocks get made, they go on the longest chain. So let's say finally, after like days, because like I said, she's just on her shitty laptop, it takes her a long time to find the nonce just for like one block. There's going to be way, way, way more. And then she's like, oh, hey, I found a nonce. But nobody cares because blocks have already been made and everybody else has been left behind. And Tomasz Pilaj just told me that the evil Alice example is completely wrong. So I really hope that Tomasz Pilaj will tell me how I'm wrong afterwards, and we'll all be smarter for it. That would be great. So sorry, everybody. I just lied to you. I'm glad that there are smarter people than me in this company because, yeah, I don't know what I'm doing most of the time. All right, so let's just talk about this, though. Let's talk about how we could hack blockchain and make a lot of money. You ready? All right, step one. Just get billions and billions of dollars. All right? You with me? Let's do it. Cool. Now we need to go to our local mining hardware store and we need to buy a lot of hardware. All right? And it better be a lot because we need to be able to make 51% of all the mining power in the world in order to be able to keep up with everybody else. Oh, yeah. Then we can start making whatever Bitcoin history we want. We want to make everybody give us all the money? Great. Have a ball. Oh, yeah. The next thing, though, is that if you do this, Bitcoin's going to become worthless. Nobody's going to want to use Bitcoin anymore because suddenly it's going to be Thomas's Bitcoin and I get to manipulate whatever I want and nobody's going to trust that ever again. Everyone's going to sell all their Bitcoin and get rid of it. It's going to crash to nothing because if people wanted some centralized currency, they would have just used regular money instead of Bitcoin. So then I get to sit there on my mountain of shit looking like a sad clown because Bitcoin is just nothing now. So that kind of also de-incentivizes people from cheating because if they were to like really cheat and take control, then, well, it would all just be kind of worthless. So anyway, once again, the steps are there's a global state that pretty much contains everybody's balance, how much money they have. Every block kind of represents a change to that state, like a snapshot in a moment in time, and they make a chain together. Whatever has the longest chain is considered to be the current state of the system, and that kind of prevents poor cheaters like you and me from gaming the system. And then new blocks are mined to finalize transactions and then to add them to the public history so that everybody can verify that it is true. All right, everybody still with me? Cool, that's Bitcoin. And then along came this guy, Ethereum, in 2015. And what if I told you that with Ethereum, you could make some Turing complete code that would run on the blockchain and that instead of just taking care of people's money, you could do all kinds of things. Well, what if I also told you that Morpheus never actually said, what if I told you? And this meme is actually based on a lie. That would be interesting, wouldn't it? But anyway, so that's what Ethereum is capable of doing. Also, that's what the Near network is capable of doing. Oh, that's also what Polygon is capable of doing. Oh, also Phantom and yeah, Avalanche and this guy, Solana. But we're just mostly talking about Ethereum right now because that's the main one I researched for this brown bag. All right, so remember how I talked about the Bitcoin steps, people submit transactions, blah, blah, blah. All right, the most important part here is that miners take a transaction and they apply it to the current state and they get the new state for it. And if you think about it, transactions are kind of just like really basic shitty functions. You know, you have the state, you have a transaction, you plug it into a function, you get a new state. So if we were to write this in like really bad JavaScript, we would just have this send money function, right? You take the state, you take a transaction, you take out the sender receiver amount from the transaction, make a new state, you deduct the amount from the sender, give that money to the receiver, and you just return a new state. And then every time you want the new state, you just call that function with the transaction and the state in there. So the way that Bitcoin works is that, the state is just a bunch of mappings from people's wallets to their money, everybody's balances. However, in Ethereum, it's a bit different because you also have wallets, like in Bitcoin, people have money. You also have smart contracts, which contain money, or they can also store any other kind of data you want. And they also have functions for manipulating that data. And so kind of like the standard thing being like, Alice has 10 Bitcoin, Bob has 10 Bitcoin, Cassie has 10 Bitcoin, all saved in the state. In Ethereum, you can have that. And let's say we could have our, I want to make a favorite color smart contract. And it just contains a dictionary of favorite colors and, people pointing to their favorite colors. And there's a function that you can call that says set favorite color. Well, how would that work on the blockchain? Well, let's see. So we have this here. This is just a recapitulation of what was there before. And let's say Cassie says, I want to call set favorite color. I want to set my favorite color to blue because my name's Cassie and I like blue. And so what happens is that all the miners set to work trying to mine that block. So they call this function on the current state to get the new state. So that means that this smart contract will now have Cassie blue inside of it. And then it's just the same old game that They just set to work trying to find a nonce that will hash together to make something that's less than the difficulty. And then they'll just calculate it and eventually add it to the new block, to the chain. So they would try some nonce of 5489. If you hash 5489 with the state and the previous thing, is it less than 10 million? No. You just keep trying over and over again. And then when it finally is there, let's say it's 4F49, whatever, that hashes to Fafa, and Fafa becomes the new ID. This gets added to the state. And then, pretty much everybody can verify, well, yeah, if we do hash together the previous and the current state and 4F49, it does, in fact, hash to Fafa. And Fafa is, in fact, less than 10 million. So cool. Everybody agrees. Consensus is reached. And then if Bob was the one who mined that, then he gets some Ethereum as a reward. It's a little bit more complicated than that, but I just want to keep it simple here, guys. All right, so that was a trivial example. But smart contracts can also do some other things. You can store ETH on them. You can send ETH. You can call other smart contracts and other functions on them. So this pretty much allows you to programmatically send money to other people, manipulate data, save things in a way that's completely transparent. And so that's kind of cool, I guess. I don't know, we'll talk about that in a bit. And so the smart contracts can either modify their own state, they can save money, they can call functions on their smart contracts. But the most important thing is that this new state is always calculatable. And so pretty much you can just call the current state or look at the current state, call a function on it, you get a new state, and then you can put that into a block. And that's how it works. So let's say, for instance, Alice and Bob want to make an annoying tech startup, and they want to name it some annoying tech startup name like Techify or Techly, or I can't do this anymore. I prefer the term New Tech Wunderbar. So they're going to make some new, what's the word? Startup. A new startup named New Tech Wunderbar. And because they're, some new tech startup, they want to go and make they want to have it all working on smart contracts here for their bank account. So they could probably make it to where, well, you can add money. Alice and Bob both can. Also, their clients can pay money to this bank account whenever they sell stuff to them. But let's say Bob has a drinking problem and he can't really be trusted with the company's finances. And let's say every time he wants to take money out, then, well, he has to get Alice's permission. Or let's say, for instance, whenever they want to spend money, let's say on, I don't know, a new foosball table or something like that, they both have to approve the transaction. Well, that can be done in like 20 lines of code. You just like do this. I mean, this isn't real Solidity code, but it demonstrates the point. It's not very hard, honestly. The interesting thing, though, is that at least in Ethereum, smart contracts are immutable. So that means once you deploy them, you can't change them. So that can also be good, but it can also be bad. It's good because it means that if Bob really feels like going out on a binge drinking adventure with his friends, he can't just go and modify the code and get the money out. but also it means that if you have some horrible onerous bug in your system, you can't really do that. You can't really fix that so easily either. So it's an interesting double-edged sword. And also interestingly enough too, the code is public on the blockchain. Anybody can read it. So, transparency, baby. That's what everybody likes. And so you've probably also heard about a lot of all these tokens on the internet. There's like Uni, there's Mana from Decentraland, the one that looks like pyramids. There's BNT from Bancor, there's DAI, all these. What is that? It's actually just, they're each different smart contracts on the Ethereum blockchain. That's all they are. And it's really easy to make them, actually. I made one in like 20 minutes, and I'm not a genius. So like, pretty much there's just this interface called ERC20. It's just like a list of functions your smart contract has to implement. Like one is balance of, that pretty much just has a mapping of like who owns how much of your particular token or whatever. So in this case, Alice owns 2,000 Uni and Bob has 376 Uni or whatever. There has to be a transfer function to where people can call it when they want to send money or send one of these tokens to somebody. And there's like a couple others, but it's not hard. It's not hard at all. And it's actually kind of cool though, because you can write custom code. You can write custom code for these behaviors. So you can make them do much more interesting things than just regular ETH or Bitcoin. For instance, like the Uniswap one, the one with this annoying unicorn, it's a governance token. So that means that if you own any Uni, whenever the Uniswap protocol wants to make any changes to their thing, like if they want to implement a new feature or if they want to do something else, if you own this token, if you have any tokens, you can vote on it and you can kind of decide what this protocol is going to do. So that's interesting, at least. At least for me, one of the things that's really, really interesting are stablecoins. So these are also just regular ERC20 tokens. They're smart contracts, essentially, but these are pegged one-to-one with real-life money. So for instance, you can, I'm just going to close this. It's really distracting. So pretty much, like if you have one DAI, which is that yellow one, or one Tether, which is the green one, or one USDC coin, whatever, each of those is just worth $1 each, all of the time, unless something goes terribly wrong. And something has gone terribly wrong recently. If you've heard anything about Terra, look that up. Like a month ago, things went really bad with it. But anyway, so the idea is that these will always be worth $1 for each token you have. And they can do some really interesting things, like if ever the price really goes up for them, they can programmatically automatically print new ones to like inflate and come back down to $1. And if they somehow get worth less than $1, they can do some other financial black magic that I don't understand in order to bring the thing back up. And so it's pretty cool. And what I think this means is that there's actually a real means of exchange now. I mean, okay, so you all know probably like Paralelní Police here in town, and it's all cool and gimmicky, like, hey, you can buy your coffee with Bitcoin, everybody. And like, yeah, I don't want to do that, I don't think, because like, what am I going to do? I'm going to go and spend some amount of Bitcoin on a coffee, and then tomorrow the price triples? Come on, like, I want to hold on to that Bitcoin. I don't want to go and just spend it away on coffee. Or let's say tomorrow Bitcoin goes way down and suddenly I have to pay triple the Bitcoin for a cappuccino. I don't want to do that either. But if we were to use stable coins, it's always pegged one-to-one. So you don't have to worry about that at all, unless the system tanks. But, just we'll worry about that another day. All right, or there's another example here. Let's say we have Farmer Bob over here with his wife, Patsy, and they own a farm and they want to insure it. And they could either go to an insurance company, or we, smart developers that we are, can make a smart contract that'll do it for us. And, we can pretty much make it to where Bob just pays in his insurance dues every month in stablecoin, because stablecoin's the way to go. And then also, if we happen to have like some freak snow in June or whatever, there's actually a way to get that information on the blockchain with a thing called oracles, which I don't have time to go into. But just trust me, it's a way of getting real life data onto the blockchain. Our thing can go and check, hey, wait, is it June and did it snow? If it did, we can give him a payout because more than likely his field got messed up in the snow. Granted, it's not like 100% because we don't really have a way of checking whether or not his crops actually died on the blockchain, from what I know. But it's an interesting case in point. And well, I'm not the idea guy. I'm just some dumb programmer. So you guys figure it out. And there are also a lot of other things you can do. There's this whole thing that's come out from this called DeFi, or decentralized finance, which pretty much just lets you do all kinds of interesting things with tokens and coins that you just normally can't do, let's say with Bitcoin. Like Aave, this one here, you can actually take your, let's say Ethereum if you want, whatever. you can actually loan it out to people, and then you get interest in Ethereum on it. And then when you're ready, you're just like, yep, I want it back. And you do, and you get your interest on it. Pretty cool. Or you can also borrow whatever kind of coin you want. There's also ways to swap tokens for others. So if I want more Uni tokens or whatever to vote on Uniswap's next thing, I can swap some stable coin for it or whatever. And this is all made possible because we have smart contracts. Another interesting thing are bridges, which pretty much let you take coins and tokens from one blockchain and move them over to a completely different one. So for instance, like if I have some ETH on Ethereum, if I want to send it over to the Polygon chain, Polygon is a completely different system, completely different blockchain, all that stuff. It's separate. They're not actually interrelated yet, but you can use a bridge you deposit your Ethereum on one side of the bridge and you get Ethereum in Polygon on the other side. So that's also pretty useful. Another thing you guys have probably heard people talking about are NFTs. Well, all right, I could probably do an entire brown bag about NFTs, so maybe I will. Who knows? Depends on whether you guys are interested. But suffice to say, what they are, you can kind of think of them like real life objects that exist in like the digital world. So like every NFT is actually unique and it's uniquely identifiable. And you can also go and like take one and you can like give it to someone or sell it or buy one or whatever. And the interesting thing is that if you have some NFTs, some of them give you certain benefits depending on whether you have them or not. Like there's this one game, actually there have been several games online where you can purchase real estate online and then you get like a deed to this patch of real estate in the game and you own that. Like under normal circumstances, the game could just be like, well, you can't really buy or sell this outside and it'd be really hard to do. But with NFTs, like you own this in your, let's say, Ethereum wallet, and you can sell this deed to someone else for real money, and then they have that patch in the game, and you have a lot more control over it. So that's kind of interesting. Another thing is that if you look at this multicolored madness over here on the side, this is actually an NFT from Colors of Ostrava that happened this past week. They apparently are issuing an NFT for auction right now. And if you win it, if you own it, pretty much, as long as you hold it, you get 2 free VIP tickets to Colors of Ostrava every year, as long as you hold it. And that's kind of cool. And if you're ever tired of it, you don't want to go to Colors anymore, you can sell it, and the person who has it will then go and have it and be able to get those benefits. So, kind of interesting. Maybe you can do something with it. I don't know. Maybe you could also just implement this in some regular centralized kind of scheme, but you tell me. So quick recap then. The blockchain is just a public repository of data. Anybody can take a look at it. Anybody can interact. And it's also really hard to cheat. So everyone's kind of got to be honest up there. We have different blocks. Each one kind of represents just like a snapshot of the global state at any time, or like how much money people have, or what data is on what system or whatever. And blocks reference the ones behind it. And it's also really hard to make new blocks because that makes it hard to fake and to forge stuff. And also, if you change the history, like this one back here, it's going to change your ID. That means you're going to have to change this one. That means you're going to have to change this one as well. And it just becomes really difficult. So, oops, that's wrong, right? Yeah, so you're going to have to change all of them, and that's no fun. All right, so the ID is actually just like a hash of all the things that are inside of a block. So you have like the previous ID of the block behind you. You have the new states that you're saying it's going to be, and you also have the nonce. And mining is just the process of trying to guess the right nonce that will make your ID be correct. Correct meaning that it's like less than some difficulty level. And in order to be able to cheat, you need to have like 51% of all the mining power in the world. And that's kind of hard. It's pretty expensive. So it's a bit difficult to cheat. With Bitcoin, the state just pretty much stores everyone's money. In Ethereum, at least, you have wallets that store people's money, and you also have smart contracts that store money and also other data. And that enables you to do all kinds of crazy stuff. Like you can have tokens, you can have stable coins, you can have all these different things as a result of the data that you store inside of them. Also, interestingly enough, all this is quite, well, it's Turing complete, so you can run regular code. So another sad kind of story is that there's this thing called crypto kitties. I don't know if any of you know about this, but it's a game with NFTs, and each NFT is one of these kittens that you have, and you can breed them, and they have certain characteristics, and they're just pictures of cats. And this one here, this dragon crypto kitty, sold for $1.3 million. Like, and that's It just kind of shows how ridiculous this is kind of getting. Like, this is just a picture of a cat with a dragon tail, and somebody bought it for $1.3 million. I mean, I can understand, like, the one with colors of All-Star, like, okay, yeah, you have something interesting and you get a real life benefit. But yeah, it's just funny to see the way the internet is going with all this. So, final thoughts. Is Bitcoin going to the moon, baby? I don't know. Maybe. But I think the blockchain is interesting, and like it or not, I think smart contracts might be here to stay, and they do open up some new possibilities. But like I said, do they really solve a real problem? Like, is this actually revolutionary, or is it just something like trying to make solutions to problems that don't really exist? I don't know. Actually, I'm curious to ask you guys, because I feel like I'm kind of at this place where I think, this seems kind of cool, but also I don't really know like how this could be used. So I would also like to ask your opinions and ask you all what you think. So anyway, that's about it. Thanks, everybody.